ask in exam point of long question, explain about DES algorithm or discuss or illustrate any kind of word they ask, explain your DES algorithm. So what is the DES? Data encryption standard. So this data encryption standard should be converted from the plain text to ciphertext. Any bits use chestunama? 64 bits will be used for plain text. How many keys are used? 56. Any keys use chestaru? 56. So here, initial permutation. We have initial permutation and here permutation choice, left to circular shift, okay, inverse permutation. After that, we'll get the cipher text. So last, listen. Initial permutation is standard, the standard table. Okay, I will show you. Amma here, listen. Initial permutation, this is the box. And inverse permutation, this is the box. And expanded E, expanded permutation also E. This is all standard values. These are all standard values. So when you given the data, when you given the particular algorithm, when you given the particular text to the particular algorithm, that will be what will happen? There will be jumbling, means they will be changed. They will be change the position. So then change the position. So what will happen? According to when you have a 64 bits, the 64 bits what will happen? They will be changed like this. Any value will be replaced. ఏం చేస్తుందమ్మా? రిప్లేస్ చేస్తుంది. ఓకే, ఇప్పుడు మీరు రిప్లేస్ చేయకుండా వాల్యూస్ పంపిస్తే ఏమవుతుంది? యాస్టీస్ ఏమవుతుంది? సేమ్ టెక్స్ట్ పంపించినప్పుడు ఏమవుతుంది? సేమ్ టెక్స్ట్ పంపిస్తే ఏమవుతుంది? హాయ్ అని పంపించాము, సేమ్ హాయ్ అని రిసీవర్కి వెళ్ళింది, ఏమవుతుంది? హాయ్ కాడ ఏం రాస్తాడు? బాయ్ అని రాస్తాడు అనుకో. వాట్ విల్ హ్యాపెన్? ద డేటా విల్ బి చేంజ్. ఫ్యాబ్రికేషన్, మాడిఫై ద డేటా. మాడిఫై డేటా. నేను 10,000 రూపీస్ పంపించిన, 10,000 కాడ ఇంకో జీరో యాడ్ చేసి 1 lakh పంపించింది అనుకోండి. అప్పుడు ఏమవుతుంది? డేటా విల్ బి చేంజ్. సో డేటా విల్ బి చేంజ్ మీన్స్ దెర్ ఈస్ నో సెక్యూరిటీ. దెర్ ఈస్ ఏ సెక్యూరిటీ లేదు అక్కడ. సెక్యూరిటీ లేదన్నప్పుడు మనం ఇచ్చిన వాల్యూస్ని ఏం చేయాలి? మనం చేంజ్ చేయాలి. సో చేంజ్ చేయడానికి ఇక్కడ వీ హ్యావ్ సమ్ స్టాండర్డ్ వాల్యూస్. వీ హ్యావ్ ఏ సమ్ స్టాండర్డ్ వాల్యూస్. ఇవన్నీ స్టాండర్డ్ వాల్యూస్. ఓకే, వినండి. ఇక్కడ 64 బిట్ తీసుకున్నానా? ఇక్కడ ఏం తీసుకున్నా? 64 బిట్స్. ఈ 64 బిట్స్ మనం దేనికి ఇచ్చినాము? రౌండ్ 1. లాస్ట్ నోట్ డౌన్, everyone note down. So there are 64 bits. DES algorithm, make heading is DES, data encryption standard. Okay, next round, note down ma. How many bits? Write down. Plain text is 64 bits. Plain text. Note చేసుకోండి. Plain text is how many bits? 64 bits. Key equal to 56 bits. Key equal to 56 bits. Rounds, total rounds are 16 rounds. How many rounds? 16 rounds. Any rounds ఉంటాయమ్మా? 16 rounds. How many rounds? 16 rounds. Okay, see. Round 1, round 2, round 3, round 4, round 5, round 6, round 7, round 8, round 9, round 10, like round 13, 14, 15, 16. How many rounds? 16 rounds. Here, nu plain text ichcham. Plain text ichchina tarvata we given our key, 64-bit key. So this permutation choice, what will happen? They will be remove 8 bits. How many bits will be removed ma? 8 bits. So ఎన్ని వస్తాయి? 64 లెక్కలు 8 తీసేస్తే ఎన్ని వస్తాయి? 56. సో ఈ 56 అనేది మనం దేనికి ఇచ్చాము? లెఫ్ట్ సర్క్యులర్ షిఫ్ట్. దేనికి ఇచ్చాము? లెఫ్ట్ సర్క్యులర్ షిఫ్ట్. లెఫ్ట్ సర్క్యులర్ షిఫ్ట్, రైట్ సర్క్యులర్ షిఫ్ట్. Left circular shift will be there. So left circular means left bits will be changes. Right circular shift means right circular shift will be changes. So these bits will be given to permutation choice. So this permutation choice table will be there. So that 56 bits, what will happen? They come into remove 16. So here 48 bits. The 48 bits given to what? Round 1. So this total will be given like this. So total 16 rounds. ఇక్కడ ఏమవుతుంది? రౌండ్ 1 అయిపోతుంది, రౌండ్ 2, రౌండ్ 3, రౌండ్ 4. రౌండ్ 1లో 64 bits. ఇక్కడ కీ ఏంది ఉంది? 56. 56లోకి వెళ్ళి ఇక్కడ 8 తీసేసి ఇక్కడ రిమైనింగ్ bits will be removed. Comes how many bits మా? 48. 48 ప్లస్ 16 ఎంత అవుతుంది? ఎంత అవుతుందమ్మా? ఎన్ని అవుతుంది? ఎంత అవుతుంది? గట్టిగా తినలేదు, రిపీట్ చేయలేదా? ఓకే, 64 bits. ఓకేనా? సో దీస్ 48 bits, దీస్ ఆర్ K1 అంటే ఏంది? వాట్ ఇస్ K1, K2, K3, K4, K5, K6, దీస్ ఆర్ ఆల్ సబ్ కీస్. ఇవన్నీ ఏంటి అమ్మా? సబ్ కీస్. K1 అనేది K2, K3, K4, K5, K6, K7, K8, K9, K10, K11, K12. దీస్ ఆర్ ఆల్ వాట్? సబ్ కీస్. ఇవన్నీ ఏంటి? సబ్ కీస్. మనకి ఎన్ని బిట్స్ ఇచ్చాము? ప్లేన్ టెక్స్ట్ ఎన్ని ఇచ్చాము? 64. ఎన్ని కీస్ ఇచ్చాము? 56. వెరీ గుడ్. సో నౌ, so these 56 bits we have here remove 8. Remove 8 bits. So now remove 8 bits ఏమైతుంది? 48. So 48 sub key for K2, K3, K4 up to K16, 48 bits. So ఇక్కడికి వచ్చినాక 32 bits SAB చేస్తుంది. 32 bits will be SAB. What is the SAB? చేంజ్ చేసుకుంటే ఏమంటే SAB అంటే ఏంది? చేంజ్. ద బిట్స్ విల్ బి చేంజ్. సో చేంజ్ అయిన తర్వాత ఇక్కడ ఈ వచ్చిన 64 బిట్స్ 1 2 3 4 5 6 7 లేకుంటే హాయ్ ఏబిసిడి అన్న ఇవన్నీ బిట్స్ ఏమైతే ఇక్కడ 64 బిట్స్కి వచ్చినప్పుడు SAB తర్వాత మనం ఏం చేస్తాం? మనం ఇన్వర్స్ పర్మిటేషన్ అంటే వాల్యూ అగైన్ చేంజ్. ఇక్కడ ఏం చేస్తున్నాం? మనం చేంజ్ చేస్తున్నాం. చేంజ్ చేసిన తర్వాత వచ్చిన వాల్యూ దట్ ఈస్ కాల్డ్ సైపర్ టెక్స్ట్. దిస్ అన్రీడబుల్ ఫామ్. ఇది అంటే ఏంటి అమ్మా? అన్రీడబుల్ ఫామ్. మన ఇచ్చింది ఏంది? ప్లేన్ టెక్స్ట్ XYZ. ఇక్కడ ఏమవుతుంది? అన్కోడెడ్ ఫామ్. సో ఇవంతా దీస్ ఆర్ కంప్లీట్. హౌ మెనీ రౌండ్స్ విల్ బి దేర్? టోటల్ 16 రౌండ్స్. ఎన్ని రౌండ్స్ ఉన్నాయమ్మా? 16. ఈ 16 రౌండ్స్ ఎందుకు యూజ్ చేస్తున్నాం? ఎందుకు యూజ్ చేస్తున్నాం? We need to change the position. We need to encrypt our data. Okay. This is here theory. 64 bits will be taken. How many bits will be taken? 64. How many keys will be taken? 56. How many rounds will be there? 16 rounds. So we are changing sapping. There are permutation table will be standard table. So we have to change the position. Ultimately, the 32 bit will be SAP. SAP and then the exchanging the bits. After that, we need to apply in the inverse permutation. Apply inverse permutation. So inverse permutation, one of the table will be there. According to that table, the value will be replaces. ఏమైతుంది అక్కడ? రిప్లేస్ అవుతుంది. సో రిప్లేస్ అయిన డేటాను మన ఎన్క్రిప్ట్ డేటాలో వస్తుంది. ఓకే, దీస్ ఆర్ టేబుల్స్. ఓకే, these standard tables, according to the standard tables, they will be modified. Now, this is a single round operation. Which round operation ma? Single round operation. So single round operation means what? Only round 1. Only round 1. How many rounds are there? 16 rounds. So here 32 plus 32, 32 plus 32, 28 plus 28, 56. So this data left shift, right shift operation, we have a expansion table. ఏముంది మనకు? Expansion table. This expansion table, so what will happen? This 32, 28 bits, 28 bits. 28 bits given to the which one? Left shift. This 28 bits will given to the left shift. So what will happen here? We will perform the permutation. So this permutation 8 bits will be removed. Next, how many bits will becomes? 48. How many bits will becomes? 40. So these 48 bits, this what will happen here? XOR. Which operation? XOR. XOR అంటే ఏంది? XOR operation. జీరో జీరో ఏమైతుంది? జీరో 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 10 01 11 0. So 00 0 01 1 10 1 11 0. So this XOR operation will be performed. This XOR operation will be given to the S box. S box. What is S box? Substitution box. S box and the substitution box. We have 8 substitution box. How many? 8. S1 box, S2 box, S3 box, S4 box, S5 box, S6 box. How many amma? ఎన్నునే మనకు 8 S boxes. So these S boxes we again given to the permutation. Okay, S box will value given to where? Permutation. So this permutation will get what is the value? 32. So this 32 we have XOR operation. ఈ XOR operation దేనితోటి ఉంది? దేనితోటి ఉంది? ఇది రైట్ కదా, ఇదేంటిది రైట్, ఇదేంటిది లెఫ్ట్ రైట్. ఏం చేస్తున్నాం? XOR ఆపరేషన్ చేసిన తర్వాత that receiver will be receive the bit. So now this value given to the left shift. Okay, left bits, right bits. This right bits will be given to the applied to the expansion table. Again expansion table will be performed the with key. With what? Key. K1, K2, K3, K4, K5, K6, K7, K8. How many keys total? 16 keys. So these keys we are perform which operation? XOR operation. After that we are apply what? S box, substitution box. After substitution box we will get some particular value. ఆ వాల్యూకి ఏం చేస్తాం మనము? పర్మిటేషన్ టేబుల్ అప్లై చేస్తాం. ఏం అప్లై చేస్తున్నాం ఇక్కడ? పర్మిటేషన్. దిస్ పర్మిటేషన్ అగైన్ విల్ గెట్ వాట్ విల్ హ్యాపెన్? XOR ఆపరేషన్. ఏం చేస్తున్నాం ఇక్కడ? XOR. సో దిస్ ఈజ్ వాట్ ఓన్లీ రౌండ్ 1. ఇదంతా ఏం జరుగుతుంది? ఓన్లీ రౌండ్. అలాగనే సేమ్ రౌండ్ 2, రౌండ్ 3, రౌండ్ 4. సో ఎగ్జామ్ అడిగినప్పుడు దే విల్ ఆస్క్ 2 ways. One is to draw a block diagram of complete DS algorithm, or they will maintain a round 1 operation. So round 1 operation అన్నప్పుడు సింగిల్ రౌండ్ అన్నప్పుడు ఇది డ్రా చేయాలి. ఇది డ్రా చేయాలి, ఇది డ్రా చేయాలి. This 32 base, the keys will perform a operation. How many X boxes? 8 X boxes will do what will do? Permutation. ఏం చేస్తున్నాము? పర్మిటేషన్. పర్మిటేషన్ తర్వాత ఏమొస్తాయి మనకు? సో these are S boxes. ఇవన్నీ ఏంటి అమ్మా? S boxes. So this value will be automatically internally. If it doesn't know how will be happen. ఏమైనా ఆపరేషన్ చేసేది మనకు తెలుస్తుందా? Anything will be happen in the back end, can you know? We don't know. We are sending a mail to open a mail, automatically the page will be open. Can you know that process internally? We don't. Same here, here also, that operation, the substitution boxes, the value will be changes. Okay. So these are, for example, this value will be there. This value, if you want to take, okay, this value, what will happen? This 1 and 0. 1 0 ante endi? 2. 1 0 ante endi? 2. 0 0 ante 0. 0 1 ante 1. 1 0 ante 2. So 1 0 అన్నప్పుడు 2 వస్తుంది. ఇట్లా మీకు యూ నో బైనరీ 1 2 to the power of 0, 2 to the power of 1, 2 to the power of square, 2 cube ఉంది కదా. 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4. 16 bit, 8 bit, 32 bit. 16 bit, 8 bit, 32, you know, 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. These are all bits. So here 8 bits, 16 bits, 32 bits, 64 bits, 128 bits, 256 bits. Okay. So if you want to take this value, 100 now, 1 ఎంత value అమ్మ చెప్పండి? 1001. What is the value? 98 అయితే చెప్పండి. ఎందమ్మా? 8 power? Okay, 8421. So 8421 లో 8 position is 1. One position is 1. 8 plus 1, 9. Okay, what is where it is there? Second po, ninth position. What is the value? 12. What is the value of 12? 1, 1. Okay, 1, 1, 0, 0 is the 12th position. Okay. Next, put heading is AES. So listen, AES. What is AES? Advanced encryption standard. Advanced encryption standard. Okay. So data link layer. So what is the data link layer? How many layers in OSA? So OSA we have how many layers? 7 layers. Okay. So what are the 7 layers? Okay. So here, bottom to top, the bottom to top approach, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this is which approach? Bottom approach. What is the top down approach? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So here, this OSA will be have 7 layers. So one more model is there, TCP IP. TCP IP. So TCP IP how many layers? 4 layers. How many layers, ma? 4 layers. So what are the 4 layers? What are the 4 layers? Layer, transport layer, internet layer, host to network. Host to network. So we have 4 layers. Sometimes we can host to network. We have combination of 2 layers. Host to network is the combination of 2 layers. Physical layer and data link layer. Physical layer and data link layer. Here, first one is application. Next, transport. Internet layer. Last one is host to network. Okay. These are 4 layers. So today internet is based on which model? TCP IP model. Which model? TCP IP. The entire functionality works which layer here? TCP IP. So this TCP IP model we can also call as. So what do you call? Internet internet model. Which model, ma? Internet model. Why? Entire internet is based on which model? Internet. Okay. So these are layers: application layer, transport layer, internet layer, over to network. So here, every layer we have discussed protocols. Application layer will be discuss the protocols. Transport layer will be define the protocols. Internet will be define the protocols. Host to network, there is a no protocols. అలాంటి ఏమైనా ఉన్నాయా protocols? లేదు. అప్లికేషన్ లేయర్ ఏం ప్రోటోకాల్స్ ఉన్నాయి? DNS, HTTP, FTP, SMTP, Telnet, SH. These are all layers. Sorry, all protocols comes under the application layer. HTTP. What is HTTP? Hypertext Transfer Protocol. Hypertext Transfer Protocol. HTTPS అంటే HTTPS. Hypertext Transfer Protocol Security. Hypertext Transfer Protocol Security. So this DNS, what is the DNS? Domain Name System. What is FTP? File Transfer Protocol. File Transfer Protocol. These are all protocol defined which layer? Application layer. Transport layer ఏమున్నాయి? TCP and UDP. TCP and UDP. Make very, very important. In exam point of view, will come 4th unit or 5th unit. We have transport layer. The transport layer, we have how many protocols? 2 majorly, 3 actually. TCP, UDP, SCTP. TCP, UDP, SCP. What is STP? Stream Control Transmission Protocol. What is the TCP? Transmission Control Protocol. What is the UDP? User Datagram Protocol. So these are protocol will be defined transport layer. Internet. What is internet? Internet will layer will be defined protocols IP. Which protocol? IP. What is IP? Internet protocol. So R we can also sometimes call internet networking protocol. R IP. IP there are two versions. How many versions? Two versions. What are the two versions? IPv4, IPv6. IPv4, IPv6. The next one is ARP is there. ARP protocol. Address Resolution Protocol. What is ARP? Address Resolution Protocol. What is RARP? What is RARP? Reverse Address Resolution Protocol. So these are protocol defined in internet. So today topic we are discussing layer, data link layer. So this data link layer will be contains where it is there. We have OSF which contains 7 layers. Okay. Application. Okay. Presentation. Session. Transport. Network. Data link. Physical. So these are layers. So here, what are the data given to the application to presentation, session to transport, transport to network, network to data link. So this we are discussing which layer here? Data link layer. So here the data application layer, the data comes application layer. So it will be added. Added to the header. What will added? Header. OSA బ్లాక్ డయాగ్రామ్ చూసారా OSA డయాగ్రామ్ డ్రా చేసినప్పుడు దాంట్లో హెడర్ కూడా యాడ్ అవుతుంది వెన్ యూ గివెన్ టు ది డేటా టు ది నెక్స్ట్ లేయర్ సో దిస్ అప్లికేషన్ లేయర్ ద డేటా గివెన్ టు ది విచ్ లేయర్ ప్రజెంటేషన్ లేయర్ ఏం చేస్తుంది దే విల్ బి ఎన్క్రిప్ట్ ద డేటా అండ్ decrypt the data. That data is given to the which layer? Which layer? Session layer. Session layer em chestadi? Session layer will be added some header and data. This session layer will be provided dialog control. What will provide? Dialog control. It will provide some sessions. It will provide some session. So for example, when you open a net banking account, ఏం చేశారు మీరు నెట్ బ్యాంకింగ్ ఓపెన్ చేసినప్పుడు యూజర్ నేమ్ పాస్వర్డ్ టైప్ చేస్తారు సో పాస్వర్డ్ ఇట్ విల్ టేక్ లేట్ ఫర్ ఎగ్జాంపుల్ యూ ఎంటర్ ద పాస్వర్డ్ యువర్ పేజ్ విల్ బి ఓపెన్ సో యూ షుడ్ బి హ్యావ్ టైమ్ సమ్ పర్టికులర్ డ్యూరేషన్ 4 minutes or 5 minutes. After that what will happen? Session will be expired. So these kind of things will becomes under which layer? Session layer. This session layer will be given to the data which layer? Transport layer. Transport layer, what will do? Changes the transport layer. It means should be transmit the data from process to process. Changes the process to process. Process ante endi? Process ante endi? ఎట్లా ఐడెంటిఫై చేస్తాం ప్రాసెస్ నువ్వు జీమెయిల్ అకౌంట్ ఓపెన్ చేసినావు ఏమేమి ఓపెన్ చేసినామా జీమెయిల్ అకౌంట్ ఆ జీమెయిల్ అకౌంట్ పర్టికులర్ సిస్టమ్ జీమెయిల్ అకౌంట్ ఓపెన్ చేసిన ఎట్లా ఐడెంటిఫై చేస్తాం చెప్పండి మీరు పర్టికులర్ కాలేజ్ అని ఎట్లా ఐడెంటిఫై చేస్తాం విత్ హెల్ప్ ఆఫ్ ఐడి కార్డ్ ఫర్ ఎగ్జాంపుల్ 1000 స్టూడెంట్స్ ఉన్నారనుకోండి డిఫరెంట్ కాలేజ్ స్టూడెంట్స్ ఉన్నారనుకోండి అందరు ఐడి కార్డ్స్ వేసుకున్నారు బేస్డ్ ఆన్ ఐడి కార్డ్ we can identify the particular college. Same way, when you open your account, banking account or social media account or Gmail account, how will we identify the process? It identify చేస్తారు process. Identify చేస్తారా process. So that process, how can identify with the help of port number? Identify చేస్తారు Good. So that we'll discuss later. Okay. Next, network layer. What is the network layer? The data should be converted into network layer in the form of what? Packets. It should be contain what? Packets. So that packets, what will do? The packet should be contain source address and destination address. So the packet is nothing but small amount of data. What is the packet? Small amount of data. In technical question, they will ask. In network layer, which data will be used? Frame, packet, or data? Which will you use? Packet. So packet, what is the packet? Small amount of data. So the packet will be moved from one source to destination. Move from where? Source to destination. Send it to receiver. So we can use what? Address. Address. Now our topic next. Data link layer. So data link layer, we can use what? Frame. So the frame will be contain header and tailor. The frame will be contain header and tailor. So what is the frame? What is the frame? Data link layer contain what? Data link layer contain what? Frame. So this frame will be contain header and tailor. Header. Okay. Should be contain header and tail. So frame, how many bits will be there? Frame, how many bits will be there? How many bits? 8 bits. How many bits, ma? 8 bits. So here, framing, we have methods. Framing have methods. Framing have a methods. What are the methods? Framing methods. Framing methods. Bit stuffing, character stuffing, so majorly according to your syllabus here, framing methods, bit stuffing, character stuffing. What is the bit stuffing? What is the bit stuffing? Bit stuffing and indama. Bit stuffing. What is stuffing? Bit stuffing. Okay. So this bit stuffing, listen, in exam point of view, they will ask What are the framing methods? What are the framing methods? What is the frame? Frame will be contained 8 bits. It should be contained header and tailor. What is the frame? Frame is a sequence of 8 bits. What is the frame? Sequence of 8 bits. It should be contained what? Header and tailor. So here, it will be contain some methods. It should be contain some methods. So what is the methods here? Bit stuffing and character stuffing. What is the bit stuffing? What is the bit stuffing? After every 5 consecutive ones, replace
by zero. Replace by what? It is after 5 consecutive ones, should be replaced with what? Zero. How many bits are there? How many bits are there? What? It is our replacement. For example, with data, like so sending the data is 0,
1, 2, 3, 4, 5, 0. Your data is sent to the sender to receiver. You are sending the data from where? Node to node. One node to another node. So when you're sending the data like this, how many ones are there consecutive? ఎన్ని ఉన్నాయి కన్సిక్యూటివ్ సీక్వెన్స్ ఎన్ని వన్స్ ఉన్నాయి ఎన్ని వన్స్ ఉన్నాయమ్మా 5 వన్స్ ఉన్నప్పుడు ఏం చేయాలి మనము ఏం యాడ్ చేయాలి 1 2 3 4 5 ఆఫ్టర్ 5 కన్సిక్యూటివ్ వన్స్ తర్వాత ఏం యాడ్ 0 1 0 every 5 consecutive ones it should be replaced with what 0 every 5 consecutive ones it should be replaced with what 0 what is stuffing stuff అంటే ఏంది so will be add extra bit it will be add extra bit ఎందుకు యాడ్ చేస్తారు avoid error to avoid the errors we are adding the after 5 consecutive ones should be replaced with 0 for example ఒకవేళ data in case of same data you are sending same data to the sender to receiver so there is if it doesn't change so whether it is header or data how will you identify హెడర్ మనం పంపిస్తున్నాం ఎక్కడ పంపిస్తున్నాము సెండర్ నుంచి రిసీవర్ పంపిస్తున్నాం ఏం డేటా పంపిస్తున్నాం ఫర్ ఎగ్జాంపుల్ ఇదే డేటా పంపించిన అనుకోండి ఈ సేమ్ డేటా అయినప్పుడు అది డేటానా హెడర్ అని ఎట్లా ఐడెంటిఫై చేస్తాం చేయం కదా సో వాట్ విల్ హ్యాపెన్ ఎవ్రీ 5 consecutive ones వాట్ విల్ హ్యాపెన్ షుడ్ బి యాడ్ విత్ వాట్ 0 ఇప్పుడు యాడ్ చేయలేదు అనుకోండి అది డేటానా అది కరెక్టా మనకి ఎర్రర్ హౌ కెన్ ఐడెంటిఫై we cannot be identified so we need to add 0 this is the first technique second is character stuffing అర్థమా bit stuffing ఏం చేయాలి after 5 consecutive ones it should be replaced with what 0 Character stuffing. What is the character stuffing? What is the character stuffing? Character. Characters. We are using what here? Characters. Instead of first, what is the first one? Bit stuffing. What will you use? Bits. Here we can use characters. So in this characters, we can use TLE, ETX, TLE, sorry, DLE, ETX, DLE, STX, DLE, ETX. What is the DLE, STX? What is the DLE, STX? What is the DLE? Data link, escape, start of the text. The link, escape, start of the text. This is the start of the text. This is what is the ETX? End of the text. Start of the text, end of the text. So for example, you are sending the data A, okay, A, B. It should be a DLE, STX, DLE, ETX. DLE, STX, DLE, ETX. So what is the DLE? Data link, escape, start of the text, DLE, ETX and then the data link, end of the text. Starting I told data link layer contains what? Frame. ఏముంటదమ్మా? Frame. Header, tail. Data link layer, what will do? It will be added header and tailor. So what is header? What is use of header? To identify the frame. What is the end of the bits? To identify the end of the our character. If it doesn't provide header and tailor, ఏమైతుంది? Two bits will be collide. అర్థమైందా? ఇప్పుడు ఫర్ ఎగ్జాంపుల్ hello, 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 hello. Hello, 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 hello. Collision will be happen or not? So what is use of that chain? What will happen? What will happen? The collision will be happen. What will happen? The collision will be happen. The collision will be happen means to avoid the collision fight will be happen. So to avoid the collision, what will happen? We allocate some channel allocation. We allocate some channel allocation. ఏం చేయాలి ఛానల్ అలొకేషన్ చేయాలి సో దాట్ ఛానల్ అలొకేషన్ బేస్డ్ ఆన్ ఛానల్ అలొకేషన్ ఫస్ట్ 10 minutes నువ్వు కూర్చో నెక్స్ట్ 10 minutes డి వాళ్ళు కూర్చున్నారు నెక్స్ట్ 10 minutes సి వాళ్ళు వచ్చి కూర్చున్నారు నెక్స్ట్ 10 minutes డి వాళ్ళు కూర్చున్నారు సో వాట్ విల్ హ్యాపెన్ we are allocating the channel so we are allocating the channels what will happen there is a avoiding the collisions so here these channel allocation problems we have aloha ఏమేమి ఉంది అమ్మా aloha okay next we have CSMA aloha and CSMA so aloha there are two types okay pure aloha second one is slatted aloha okay pure aloha slatted aloha so pure aloha so randomly they are allocating the channel there will be happen a collision so that is comes under the pure aloha slatted the name indicate what slatted so slatted what will happen they will be allocated some slash the based on the slash the data will be transmitted data will be transmitted so what will happen we are avoiding the collisions next one is CSMA what is CSMA what is CSMA carrier sense media access sense మనం ఏం చేయాలి సెన్స్ వాట్ విల్ డూ క్యారియర్ చేసినప్పుడు ఏం చేయాలి మనం సెన్స్ ఫర్ ఎగ్జాంపుల్ మన ఒక ఫ్రెండ్ ఇంటికి రిలేటివ్ ఇంటికి వెళ్ళినాం ఓకే మన రిలేటివ్స్ ఇంటికి కానీ మన ఫ్రెండ్ ఇంటికి కానీ వెళ్ళినప్పుడు డైరెక్ట్ వీ కెనాట్ బి ఎంటర్ ఇన్ టు ది దేర్ హౌస్ ఫస్ట్ వాట్ విల్ హ్యాపెన్ వీ నీడ్ టు బెల్ ద డోర్ ఆర్ రింగ్ ద సో నాక్ ద డోర్ వాట్ విల్ హ్యాపెన్ వీ నీడ్ టు నాక్ సో ఆంటీ ఉన్నారా అంకుల్ ఉన్నారా లేదా మామయ్య ఉన్నారా డాడీ ఉన్నారా లేదా మనం ఏం చేస్తాం మనం ఫస్ట్ డోర్ కొడతాం సో బెల్ కొట్టినప్పుడు ఆటోమేటికల్లీ దే ఇఫ్ యూ హ్యావ్ ఫ్రీ దే విల్ బి ఓపెన్ ఏ డోర్ if they are free they will be open a door if they are busy what will happen we need to wait random amount of time మనం ఏం చేయాలి అప్పుడు వెయిట్ చేయాలి that mechanism will be used here CSMA okay first one is channel allocation aloha second one is CSMA so under the comes under your third unit this aloha we have two types pure aloha slatted aloha so pure aloha em chestadi there is no allocation based on the data there will be transmitted so sometimes what will happen overlapping em jarugutadamma overlapping మీ క్లాస్ లో దాని బయట ఎన్ని ప్లేసెస్ what will happen when you sit in RTC bus what will happen in the instead of 3 members you sit 4 members what will happen the collision will be happen overlapping will be happen so that comes under the pure aloha this pure aloha will be give 18% how much accuracy probability 18% if you use slatted aloha that should be give 36% there is a allocating some slots ఇక్కడ ఏం అలొకేట్ చేస్తున్నామా మనము slots based on the slots first slot time slot next time interval కాగానే next so dividing the time slot intervals the data will be transmitted so to avoiding the collisions we get 36%. Here, this is the one of the scientist name, Aloha. Okay, but tomorrow we'll discuss. CSMA, carrier sense media access. So in the sense means we need to sending the data. First, we can need to ask the channel. We need to ask the channel. Channel. Are you busy or free? If it is busy, we need to send the data. If it is if it is busy, we need to wait for some random amount of time. If it is free, we need to send the data. That comes under the CSMA. So if you, for example, when first we need to knock the door. If they are free, they will be open the door. If it is busy, will we wait for the some amount of time. So that's what will happen. We were waiting random amount of time. So here the accuracy will be comes. That comes under the channel allocation. Okay. So here, in this channel allocation problem, third unit, one more topic, channel allocation, TDMA, FTMA, okay, CDMA, TDMA, FTMA, CDMA. What is the TDMA? TDMA అంటే ఏందమ్మా? Time division, multiple access. What is the TDMA? What is FDMA? Frequency division, multiple access. What is FDMA? Frequency division, multiple access. What is CDMA? మీకు లేదు సిలబస్ లో. Code division, multiple access. So time division, multiple access. The name time. The name indicate what? Time. The name indicate what? Time. Here F. What is F? Frequency. Frequency division, multiple access. So the frequency division, multiple access. The time division, multiple access. C for what? Code division, multiple access. If you want accessing the channel, we can use either time, either frequency, either code. Based on the frequency, allocate the channels. Okay. For example, 50 Hz frequency. The frequency 50 Hz, what will happen? They will be allocated. For example, this is the 25, 20, this is the 20. So, okay, like that. They will be allocating the frequency. So, or if you want to take like this also. $25. The frequency edges will be allocated. Time division, time intervals. For example, intervals, based on the time, they will allocating the time intervals. So here, why we need to allocate this question ఎందుకు రావాలి? So means when you allocating, sending the data from sender to receiver, so at a time all sending the data, what will happen? The collision will be happen. So to avoid the collisions, we are using some channel allocation problem. So this channel allocation we can use MAC, medium access control. So this is the medium access control. So this is a sublayer of the data link layer. So this what will happen? The channel allocation problem, we can allocate the channel based on the some methods. So what is the first method? Aloha. Aloha, what will do? Is the scientist name of the Aloha. The Aloha will be two categories. Pure Aloha. Second one is slanted Aloha. Pure Aloha, we are sending the data from sender to receiver. The data will be sending. So what will happen? The collision will be happen. So here what will happen? Some data will be lost due to noise. So you should be give how much throughput? the output should be 18 percentage. If you take slotted ALOHA, the slotted ALOHA, we are sending the data through slotted way, allocating some slots. So what will happen? We are to sending the data from source to destination or sender to receiver. So it will be give accuracies. Throughput is 36 percentage. So next one is CSMA, channel carrier sense multiple access. If you want to accessing the particular channel, we need to make a sense particular channel. So in this carrier sense CSMA, there are three. One probability, P probability, 1 minus P probability will be there. So based on the probability, if the channel is free, we need to send the data. If the channel is busy, we need to wait for some random amount of time. That comes under the channel allocation. So CSMA. Next one is CDMA, TDMA, FDMA. TDMA అంటే ఏంటమ్మా? Time division, multiple access. So time division, multiple access based on the time intervals. So we are allocating the times. We need to send the data. We need to allocate the particular media. Medium will be allocated. How will you allocate it? Time. ఎలా allocate చేస్తామమ్మా? Time. How will you allocate in the media? Assessing based on the frequency. We are given the some frequency. If you are allocating the CDMA, we can use how? Okay. If you take nowadays 3G phones, the 3G, 4G will be used this CDMA technique. Third generation mobiles will be used which techniques here? CDMA. Okay, code division, multiple access. So now, so today lunch 12, 12, 12 to 1. So here, what is the today class? Today we'll discuss data link layer. So how many layers in OSI? 7 layers. How many layers in OSI? Sir, TCP IP. What are the 4 layers? Application layer, transport layer, internet layer, host to network. OSI, 7 layers. What are 7 layers? Net data link layer and physical layer. So that is the top approach, top to bottom approach. So here, what is the functionalities of design issues of data link layer? Framing, error correction, error detection, flow control, channel allocation problem. So first here, frame. What is the frame? What is the frame? Frame is sequence of 8 bits. It should be contain header and tail. So framing, how many methods? So majorly three, actually three. So we can use here two. What are the two? Bit stuffing and character stuffing. What is the bit stuffing? Every 5 consecutive ones, it should be added 0. What is the header length? 0, 6 ones, 0. What is the header? 0, 6 ones, 0. How many bits total? 8 bits. హెడర్ ఎంత ఉంటుంది 0610 అంటే ఎంత 8 టేలర్ ఎన్ని ఉంటాయి 061 0 how many bits 8 bits in character stuffing it should be character stuffing means adding stuffing means what adding why you are adding in frames to avoid the overlapping or to avoid the collisions what is the DLE data link escape what is the DLE data link escape what is STX start of the text. What DLE ETX? What is the DLE ETX? Data link escape end of the text. The text will be ended. Okay. Next one is second issue is error correction and error detection. What is error detection? Detect the error. Error detection is what? Detect the error. So how we detect the error? How we detect the error? There are three methods: single bit errors, parity bit error, CRC, checksum. CRC, what is CRC? Cyclic redundancy check. Next one is, what is checksum? Checksum is used for the error detection. So how we detect the error? How we detect? If you're sending zero, if you're sending zero, the receiver will receive what? One. ఏమైతుంది అప్పుడు? ఏమైతుంది? Sender sending zero, receiver will be receive what? One. Correct data, error data. ఇక్కడ ఏం జరిగింది? ఎర్రర్. ఏమొచ్చిందమ్మా? సెంటర్ ఏం పంపించండి మనకు? జీరో. మనం ఏం రిసీవ్ చేసుకున్నాము? సో వాట్ విల్ హ్యాపెన్? ఎర్రర్. Parity error, even parity error, odd parity error. Okay, that will be discussed by tomorrow. Okay, even parity, odd parity, that will becomes under the error detection. CRC means cyclic redundancy check. So we can need to check the error. So next one is checksum. Checksum means we need to add, we need to make a ones complement. If get zero, error detection low, CRC gaani, checksum గాని, చెక్సమ్ లో గాని, ఇఫ్ రిమైండర్, రిమైండర్ లో ఇదండి అమ్మా, రిమైండర్ జీరో అయితే, రిమైండర్ జీరో అయితే ఇది వాట్? యాక్సెప్టెడ్. రిమైండర్ జీరో అయితే ఇది వాట్? యాక్సెప్టెడ్. ఇఫ్ ఇట్ ఈస్ వన్, రిజెక్టెడ్. సో దట్ ఈస్ కమ్స్ అండర్ ద ఎర్రర్ డిటెక్షన్. వాట్ ఈస్ ఎర్రర్ కరెక్షన్? Correction means humming code. So instead of, if we get, so for example, if we get zero, we need to identify this error. Okay, so we need to modify. Okay, for example, if we're sending the data 1, 1, 1, 0. Sorry. Sender sending the data is 111, 0. Receiver will be receive the data is 0. Receiver will be receive the data is 0. So where it is happen error? Where it is happen? Here. So this error we need to identify. 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. So this position we need to correct the error. That comes under the humming code. Next one is flow control. What is the flow control? Flow control. So if you want to sending the data, we need to, based on the receiver acknowledgement, we need to send. So without acknowledgement of the what will happen, data will be lost. Data will be lost. So sender will be very fast, receiver will be slow. So that time what will happen? We need to take acknowledgement from the receiver. Based on the acknowledgement of the receiver, we need to send the data. So in this flow control mechanism, so we have sliding window protocol. Sliding window protocol is there. Okay, and next one is stop and wait ARQ and go back in. Next one is selective repeat. Selective repeat ARQ, go back in. And next one is stop and wait ARQ. Very, very important is sliding window protocol. Sliding window, just a window in the bits will be there. One bit will be changed, move from one position to another position. That is a sliding window protocol. So next one is channel allocation. What is the next one, Ma? Channel allocation. What is the channel allocation? We are allocating the channel. So we are allocating the channel. Without allocating the channel, what will happen? Data will be, collision will be happen. Data will be lost. To avoid that problem, we need to go for the medium access control sub-layer, the MAC layer. So we can use some allocation problems, random allocation problem, static allocation, dynamic allocation. Two types ఉంటాయి. Static allocation, dynamic allocation. So static allocation, dynamic allocation, based on that allocation, we need to allocate the channels. So first, if we take Aloha, hello, there are how many types, Ma? Two types. Pure Aloha, slotted Aloha. The pure Aloha, we need to sending the data to randomly. So what will happen? Sometimes data will be transmitted, sometimes the data will be, collision will be happen. Next one is slotted Aloha. So based on the slot data law, we need to allocating the slots. So data will be transmitted. So there is a no collision will be happen. Next one is CSMA. What is CSMA? Carrier sends multiple access. The carrier sends multiple access. We need to changing the channel. We need to send the channel. The channel is free. We need to send the data. The channel is busy. We need to wait for some random amount of time. That comes under the channel allocation. So next we have one mechanism, TDMA, FDMA first, FDMA, TDMA, CDMA. So what is the FDMA? Frequency, division, multiple, access. What is the frequency? We need to allocating the bandwidth frequency. Based on the frequency, we need to send the data from this node to node or sender to receiver. Next one is TDMA. What is the TDMA? Time division, multiple access. What is the time division, multiple access? Based on the time, based on the time intervals, so we need to send the data. For example, your class time is 9:30 to 12. So based on this time intervals, classroom cannot allocate to the others. You cannot allocate the others. Why? Because if you are allocating someone, so just now my class, instead of that, what will happen? The collision will be happen. Same way, if you have someone allocate, what will happen? The collision will be happen. So to avoid the collisions, we have some mechanism, time division, time based on time, based on the frequency, based on the code, we are allocating the, we can accessing the particular channel. This comes under the third unit. Okay. Thank you.